Now that the sound is on, Calvin, hopefully you feel better. Don't know if you're watching the videos, but my guess is you've turned them on and realized that you know it. So, exponents, right?
No.
What? No exponents?
No exponents.
Okay, well, I guess we just won't do anything today then. Good job. No. So, exponents. So we talked yesterday about our multiplication strategies with the exponents, and we just have a little bit more to cover to make sure that we know all of those exponential rules. So yesterday we talked about a base with an exponent with another same base with a different exponent being multiplied or divided. What does multiplication or division really turn into when working with the exponent values?
Wait, say it again.
If I have like x to the third times x to the fourth, what actually happens? I know, give it a second. What actually happens with those exponents, Brian?
They do the addition.
They add. What if we were dividing?
Well, then they do the subtraction.
Then they do subtraction. If Smart Ink is ever going to come back.
You were thinking it. You know multiplication and division,
What is the little tail? We got to use math words. Yeah, it's just roots. So, anytime we have a fraction as the exponent, it's actually a root or a root with a power if the fraction has a numerator that is not 1. So then, what happens when we have a value raised to a power raised to a power? So a power to a power. That actually then will multiply. So when you're raising a power to a power, that's like saying we have a set of 4 5s, and then I have 2 sets of those 4 5s. So in total, I have 8 5s. Any questions on a power to a power multiplying the exponents? And then a product being raised to a power essentially applies your distributive property. Because this actually multiplies, this really is like the distributive property, distributing the multiplication to the exponential values. Brian?
Can I grab the packet that we're supposed to have today?
Yeah, you could also try to keep papers where they belong. That would be, more helpful. Sure, Brian, if that works for you.
He's gonna return this like some goldfish.
I'll take them. So, any questions on our properties? Because then we're going to use cards. So, Emma, if I have n to the 4th to the 7th, what would that turn into? N to the 28th. Now, what about, Rhea, x to the 2/3 to the 1/2? Don't try to jump all the way to the end. Just do one step at a time. Yeah, we multiply straight through those fraction values, so I get x to the 2/6. Now that's the question. Should we reduce this? So we know fractions can be reduced, but let's compare. Because we want to know, we want to check, is this allowed? So we could do x to the 3rd, or we could leave this as x to the 2/6. Does anyone know right away? Can anyone explain why we would or would not reduce? Carmen?
I can say why we might not.
Okay.
What a reason would be. It might come out different when you, square root it.
So this would be like the 6th root of x squared, right? This would be the 3rd root of x. So if we compare, just to check if I'm allowed to reduce fractions and exponents, choose a value for x. So what if x was 2? 2 squared would be 4. I get the 6th root of 4. Or I could break up the 4 into the 2 and the 2. Long story short, we can reduce. Just be careful when you do it. part of our simplification process, if you have a fraction in your exponent, you can reduce it because this would come out to be the same values. You'd either get the cube root of 2 or the 6th root of 4, which those values are the same. Any questions? So, and again, that came from one year somebody arguing that we would get a different answer if we reduced versus if we didn't reduce. So then we had to play through multiple situations and prove to them that you do get the same results actually. So for our got it here in problem 1, p to the 5th to the 4th, Ethan, this becomes?
P to the 20th.
P to the 20th. We multiply those exponents together. Now, we have y to the 3rd times y to the 5/2 to the -2nd. So Caleb, what do you think we should do first?
You don't have any values. I'm just gonna say go from left to right. I'm not exactly sure of that though.
So follow order of operations, really.
Yeah.
Right? Because, I mean, it's saying left to right, that goes back to kind of order of operations work.
Yeah, and I couldn't find anything here that actually had, since there's no values for y.
Okay. So do I have parentheses that have something happening inside of it?
I guess you do.
Don't just default to Straveler. What do you think? Can I do what's inside that parentheses?
No, you can't.
No. So then I move on to, is there anything I can do with the exponents?
And no. Wait. No. Oh wait, yeah. Can you?
That's what he was asking you.
Oh. I thought that was. Oh, okay. Yeah, okay. Wait, can you just? That's an exponent?
Yeah.
No. It was so low that I thought it was just doing -2.
Oh,
no.
no. That's why I said to the -2.
Oh, my apologies. All right, then yes.
Now that we're all on the same page, wonderful. So we can do those exponents. What does that become?
That becomes -10 over.
And since we just talked
that'd
about
be
the fact that
-5.
we can
Yeah, it's
reduce,
-5.
this becomes -5.
That makes so much more sense.
Then, to continue simplifying, Lynn, what can we do now? I want to take this as far as possible simplifying. How do I combine y to the 3rd and y to the -5th? It's all good. You can pass. Okay, you're good. Max?
You would add the exponents. No, I can't.
Your slippers are very fashionable. Trying not to get a positive. I know. All right. I know that Scarlett's got her taken care of. So, by the way, your 8th grade class is just awesome. So the fact that we can have safety plans that involve students helping students, it's not a great thing that we have to do that, but it's great that we trust you guys and that you're able to take care of each other. So we appreciate that. I mean, obviously you're the top notch of your group because you're so far ahead, but your whole class as a whole is just a great group of kids. So I understand you're lucky to have the peers that you do. So Max, you're saying this simplifies out to
Y to the -2 or y over y.
yeah, to go all the way we want a positive exponent. What's up, Julie?
Do you have a lost and found? Because I lost one of my books.
Only right back there. If I saw a Miss Peregrine's book here this morning, but somebody maybe took it back to the library. I don't know. I heard about a Mockingjay book in Goldring's room at the end of the day, either yesterday or 2 days ago. Did you get her where she needs to be?
Yeah.
Okay, thank you. All right, so if we want to simplify this guy, I'm going to throw it back to Caleb. So Caleb, the first thing we
That's
could
an
do.
Exponent. Let's just clarify this. That's an
All right,
exponent.
let's clarify. This is an exponent.
All right, cool. This makes a lot more sense then. So you can do work with the exponents. Since you don't know the value of x, you just do work with the exponents, which turns out into x equals negative 24. Yeah, negative 24, and you combine, and you get x to the power of negative 22. Is that correct there? Oh, wait, and you can do even more.
There we go.
You can go x, wait, sorry, 1 over x. Okay, there you go.
All the way till we get the exponents combined and positive. All the way.
I'm sorry.
The last one with the y's? We went all the way to a positive exponent. Let's say yes, we did. I thought we did. All right. So now where we actually apply needing this sort of work. So if you haven't driven down Snoffer that way, well, I guarantee you've seen this actually. No matter how long it's been since you've driven down there, you've seen, I'm sure, that there's a new retirement facility down there. And there's also a new apartment complex. And miraculously, they look very, very, very similar. Because they probably had the same builder. And when builders and architects and people like this make designs, they don't normally actually put direct measurements on it. They put like ratios or relative measurements or how one thing relates to the other thing. And then you can adapt it to where you're actually building it. So when we talk about problems like combining exponents and those sorts of things, it all comes back to the application of when will that matter. Well, if we talk about an area of some object that's going to have the size of 5x cubed, we can plug in whatever x I want and manipulate the size, and that function or that 5x cubed would still work with whatever my original design or whatever the original thing we were talking about was. So if I talk about the area of a square here, this is obviously a basic way to start. But Brian, how do I find the area of a square?
You do the one side squared.
Yeah, so the side length squared.
Yeah.
So I could not have said it better myself. Don't think length times width here. I mean, you could, but really the easier thing to do, and what we want to do to relate to this lesson, is take your side length and square it. Now this square is squaring the whole thing. So what do we want to do with that?
25x to the 6th, because you have to do the multiplication.
Yeah, it essentially distributes that power, and this becomes 25x to the 6th. So then if we knew the x, we could plug it in and solve based off that. Cool?
Yeah.
Good work.
Is this the only one we're doing? Or are we doing 3 too?
Nah, we're just doing 10-2 today. I just figured I might give you guys a little bit of time to work, and then we'll wrap 8 tomorrow. And then Monday, Tuesday of next week, we'll wrap up, like finish chapter 10. We'll wrap that on Wednesday, and then while I'm gone, you guys will take those masteries. Straveler,
Yes, sir.
do you know what this turns into? And you can work through it a step at a time if you need.
Yeah, I think. So, what is that be, like, I don't know it right now, but 7 cubed
Yeah.
times, 343 times m to the 27th. 343 m to the 27th.
And actually, since I wrote it out here, I might as well write out that this was 9 times 3 for a moment, and then we computed everything.
Did I use it? Wow.
Any questions? So, when we have an expression using the multiple variables. Now, I had somebody come and ask a question on the homework last night about, man, I forget what it was, but it was something like 2x squared y to the third. Or was it times or plus? I forget who asked me this.
For what?
I forget what operation was between them. I think it was plus. And they said, now, I'm trying to figure out how I deal with the x's and the y's because they both have x squared and y to the third. This was something close to what was on the homework. And one trick that we can apply is if I have multiple variables, but they actually, when we look at them together, have the same powers and everything, think of x squared y to the third as some other variable. So if we rewrote this as 2z plus 3z, that makes it easier to see that we would really just have 5z, and then I can replace my z with that x squared y to the cube. So sometimes when we're working with multiple variables, replace it with something easier for a moment. That doesn't relate to exactly what we're looking at right now, but I just had that thought because somebody came and asked me yesterday when they were working on their homework. So here, our variable values are different. We have no m out here. We just have n to the half to the 10th, and then 4m times n to the negative 2/3 to the third. What can we do here, Michelle?
Okay, well, first you can look at the n to the 10th thing, n half to the 10th, and that becomes 5 because it would be 10 over a half.
Mm-hmm.
Five.
Exactly.
And then you distribute the 3 to all of the things inside the parentheses. So the 4, that would turn out to be 64, I think. Yes. 64, and then n to the third, and n to the negative second.
Questions?
Oh, no, no,
So wouldn't you have to also simplify the n? No?
We're getting there. Yeah.
And then you would simplify the n by putting it as 1. Well, it would be
Look at the
n
big picture.
to the 5th, 64, n to the 3rd over. Oh, never mind. I'm paying attention. Okay. It'd be n to the 3rd.
N to the third. Don't rush to like do things. Look at the big picture. I've got an n value here and an n value here. Those can be combined, and I get n to the third times 64 times m to the third. Yeah.
I don't understand. Don't if you like with the negative 2/3 and the 3 like the 3's like cut each other.
Yeah, that's why this became negative 2.
But then why did you get 64? Wouldn't that be 16?
So it's 4. So really this becomes 4 to the third power, m to the third power, n to the negative 2 times 3, or negative 2/3 times 3 power.
Oh, the negative 2/3 is just for the n. Never mind.
Yeah.
Never mind.
Remember, the power only applies to its base, unless it's outside of parentheses, and then applies to each base in the parentheses. Thank you for the question. Caleb?
Oh, I was gonna say, question. Well, it's actually, one thing. Could we just combine that to 64 n to the third power and n to the third power?
Yeah, so actually, if this was me, you could either, and there's no like right versus wrong, you could either write this 64 n to the third, m to the third, or 64 n m to the third, or since we realized that actually 4 to the third is our 64, we could say that this is 4mn to the third
Would
if
that
we
still be
wanted
fully
to.
simplified?
Huh?
Would that still count as being fully simplified?
It depends on what you're doing. Sometimes you'd prefer to have it like this, and sometimes you'd prefer to have it like this, so I could do the m times the n first times the 4 and then cube everything, as opposed to having an input for the n and an input for the m, and like, so it depends what you're doing. If we want to be technical and say when is it simplified, this is our simplified form, where we've done what we can do. But sometimes, depending on application, it's nice to, if everything is getting cubed, multiply everything, then cube
So
it.
if like you have another step to do that one, the 4, and then to cube would be good, but if that was like the final answer, 64 would also be fine.
Yeah.
On a
Alright, cool.
test, would all of those count? All 4?
I would take either of these for sure. Yeah, I mean, yeah, I'd take any of these, but if it says fully simplify, always try to get rid of parentheses. That's what, like, if it says simplify, you're trying to get rid of grouping symbols, really. Yeah.
I have the next one.
Actually, Scarlett has the next one. Well, we hope. So take it a step at a time. Don't try to eat an entire pizza in one bite.
I mean, I don't
Can
know.
we-
Yeah, is that a
Is
challenge?
that a challenge?
If you buy the pizza,
If it's a
Nice.
really tiny
I know how to do the
It's
Heimlich.
like one of
What
those,
makes you
like,
think I'm gonna share the
3
pizza
inch
with
by
you?
like one of those
you're
pizza
not.
pizzas.
No, if you're trying to eat it in the whole. I'm just saying I'm not buying the pizza.
I
That's
have
all
a
I'm-
question.
Yeah.
What are the dimensions of the pizza?
Yes.
Like, can they do
Could I
like
do the
bagel
trick?
bites?
Yeah, you know, if you go.
Its
to
area is
Magic
pi
Mountain-
times the radius squared.
If you go to
Ah.
Magic
That's
Mountain, they
pizza.
have-
Have you guys not seen that? If the radius is z,
Yes. It's hilarious.
Oh, it's pizza.
Stop.
pizza, pi times if the radius is z. Have you never seen this? That's how you can teach little kids about
That's
area of a
that's the
circle.
thing my EPP teacher, Mrs. Wolf, would do.
Yeah.
She'd be like, that's
All right, Scarlett. There you go. There's your like to help your little cousins or brothers or whoever you have. Help them learn pizza is the area of a circle. So, Scarlett, first thing we can do, I've helped you out with some arrows here.
Yeah, so it's gonna be okay, shush. X to the wait, I had it for a second and I started thinking about pizza. Okay. That's X to the negative and we're taking it one step at a time.
Yeah,
So
I
X
agree.
to the negative 4
I never try to do all my steps at once. That's how you make mistakes. Don't even expand it. Just leave
Okay,
everything to the
just-
powers.
3 to the 4th, then X to the 4th, and Y to the 20th. Like,
Whoa.
We're gonna get there. We just knew there was another step coming, so I'd rather write it out first so we all see what's happening. So then,
then
now this is weird.
those two cancel out.
Ah, that's like x to the fourth over x to the fourth. They cancel.
They,
3 to the fourth,
81.
81. Y to the 20th.
yay.
nice.
Questions?
Nice and nice.
Snazzy.
Can we eat
You
pizza at
just
some
like
point? Like at the end of the year? I know
Sure.
that this is kind of playing
For
in my head,
Pi
but
Day,
I like
can
pizza.
we eat pie?
I mean, I do a Pi Day contest where I have pie prizes.
Hey, I got a pie.
Like, I have
last
pies
year.
as prizes.
Our EPP teacher let us brought it, like everyone brought it.
Let
some
us
pie.
brought in.
Lettuce brought in.
I
lettuce.
can't speak today, don't judge me.
You're the one that
So
said
we
the
brought in
nature.
like 60 pies, and it was awesome because we all got to eat pie during class.
You know, a
Wait,
different name for a pizza is a pie.
Well, I say like 60 pies, but that's because like.
They get so excited about
every
food.
grade also
Oh,
wanted
like,
it.
Mr.
can't
Hudson,
believe it.
you know a different name for a pizza is a pie, so we should also have pizza.
Yes, I know.
Yeah.
I'm not in disagreement. You guys sound like you're trying to convince me.
We
You
are-
don't have to convince me. I just need to be able to afford
Mr.
it.
Estes' rule is if we can convince you, he agrees with it. If we can convince him, it's okay.
We just like bring in pie on Pi Day and all eat pie.
Probably, but not if we never get there. And at this rate, we're stuck in the mud right now. I'm waiting.
People are
Hey guys, stop.
Hey guys.
Hey guys, homework would be fun to get to.
Yeah, I know those homeworks are long, which is why I figured we'd make it through this quicker and not try to do multiple lessons in a day, just try to give you a little bit of extra time budgeted. If we were inside yesterday, we would have made it through that lesson faster. I'm hoping to get done with this in the next 5 minutes, so you have a good 10 minutes to at least get a good start on your homework. Real problems. Aircrafts. So the expression 1/2 mv squared gives the kinetic energy in joules, that's how energy is measured, of an object weighing m kilograms traveling at a speed of v. Why do we use v for speed?
Velocity.
Velocity. What is the kinetic energy of an experimental unmanned, good thing it's unmanned, jet with a mass of 1.3 times 10 to the third traveling at a speed of 3.1 times 10 to the third? So, set this up, plug in your values. We know that energy 1/2 my m 1.3 times 10 to the third.
That's scientific if you didn't know.
No way.
Then 3.1.
Just if you didn't. I had it.
Okay, like just clarifying.
Now be careful, the only mistake I've seen here is somebody trying to apply that squared.
Excuse the interruption. Could I have Brady Cool to the office? Brady?
To the m and the v, so make sure you pay attention when there are parentheses or when there are not parentheses. That squared only belongs to the v. And then let's work through. So who can help me?
Yeah, we should do cards.
So the only people whose cards haven't come up are Carmen, Megan, and Calvin, but Calvin's not here. Would either of you like it?
I have the answer already.
Oh, you already have it? You want to help me through this then?
Okay, so I distributed the exponent of 2 to the things inside the parentheses over there,
Okay.
and got 9.61 times 10 to the 6.
Ooh, so why did you do it to both of these?
Because it's on everything within the parentheses, not just on the 10.
Yeah. And think about if I were to write this out in like standard notation, think about if I did 2 times 3 squared. Right? So if I square both the 2 and the 3, that turns into 4 times 9. But if I do the 2 times 3 first, this is 6 squared. Well, what's 6 squared?
36.
36, which is what 4 times 9 is. So that's the other mistake you need to watch out for, is both the 3.1 and the 10 cubed each get squared. So we get 9.61 times 10 to the 6th.
And then I brought down everything else.
Bring down everything else.
And then I multiplied the 1.3 and the 9.61 together and got 12.493, and multiplied the 10 to the power of 3 and the 10 to the power of 6 and got 10 to the power of 9, and then I put it all over 2. I just put it over 2, and I worked it out, and it was 6.246 times 10 to the 9th joules.
6.2465.
6.246. That's what I got. Could be wrong. Sorry about that. But yeah, it's 0.265. I just didn't write that down.
Would you divide the 10 to the power of
No.
9?
No.
Alright.
Because think about if this was in standard form, those are just your decimal points.
Okay, I got you.
So when we divide, it doesn't affect my decimal values. It affects my constant, like whatever numbers apply actually.
10 to the 9th, right? That's a 9.
Yeah, I'm trying to 2, 4.
Yeah.
Yeah.
0.6.
So it would be if we stopped here, that would be 7. So if we go to the next place, it'd be 6, 5
I didn't write
times
that.
10 to the 9th joules. So you truncated instead of rounding. When you just chop the numbers off and don't care about them.
I remember.
No, it's like sometimes we do truncate, like on purpose.
Yeah.
Do we have any other questions? Do we need to do the got it, or are we comfortable?
What?
Do we need to do the got it, or are we comfortable?
I'm good. I
Can
think
we
we're
do it
good.
just for the heck of it?
I mean, so what I was going to say is I'm going to do the got it up here. If you want to start your homework, it's not going to hurt my feelings.
Sorry, Mr. Hudson. I want to do this.
Sorry, I said it's
Said it wouldn't hurt
not
your feelings.
going to hurt my feelings. You don't need to
I
apologize.
had to make sure.
I think secretly it is hurting.
Yeah, I didn't know if it's
And you're
secretly
just
hurting.
masking.
I really would just rather like do math.
You know what?
Like, if I could just do math all day long, not grade papers, which really I guess when I say statements like that, people are like, well, just go be a mathematician. I'm like, "Ah, but I like working with kids and getting good.
Why?
Yeah, I mean, Mr. Hudson, seriously.
I
We're in
don't know.
like.
I really
All
don't.
you.
Our prime hormonal
Yeah, Mr.
stage.
Hudson, I'm pretty sure by like 40 you're gonna have gray hairs if you keep working with us.
He already has gray hair.
Have you looked at Kabila lately?
Just walk
I don't
by.
talk about it, but we all notice it.
Nobody's saying.
I feel like we I feel like we gave him at least
I
half.
feel like he
Look,
gets the worst
he
of it, though.
knows. He's aware. He's got 2 daughters now.
Yeah,
If
exactly,
anything's
that's
gonna
what
give
I'm
you gray
saying.
hair, it's having daughters.
We're in our
It's
prime
not
hormonal
bad.
stage.
My sister is terrible. I mean, my sister's awful.
All right, so if you're following along with our got it up here, I filled in my mass, I filled in my volume, or sorry, velocity, saw V and immediately thought volume. We apply the square, so if you're working on your homework, you probably do not need to be talking to work on your homework. This becomes 9 times 10 to the 4th. My 2.5 times 10 to the 5th just drops down. 2.5 times 9, 18 plus another 4.5, 22.5.
Yeah, that's right.
Yeah. Times 10 to the 9 all over 2. Do we end up with 11? Can somebody, if somebody
11 plus
did this,
5, yeah.
times 10 to the 9th?
Yeah.
Joules.
No, that's not a scientific notation.
Does it ask for scientific notation?
Oh, I just
No, it doesn't
Wait,
specifically ask for it in
Oh,
scientific.
it doesn't
So we don't have to. Now we could, which would be 1.125 times 10 to the 10th, because I move my decimal left, my power goes up.
Mr. Rhodes, I have a quick question.
Okay, quick question.
This is my. I'm not sure if there's known here, or but if there are two, what are they called, negatives in. So let's say, for example, let's say it's like 5 to the power of -4 times z to the power of -26.
What question do you want?
5 to the power of -4, z to the -26.
Yeah. How would you simplify that? I don't know if I'm just
Just add them together. Just
What
add
do
them
you
together.
need? Yeah, define them as just take that.
Okay.
25, 220, or
Would it just be
5, 625.
You're gone.
What problem are you doing?
Wait, I gotta check you.
Which one is it?
They both drop into the denominator, and then I can evaluate 5 to the 4th, which I
Oh,
think
okay.
is
I was
625.
thinking if you have one decimal, you drop both of them, and then it dropped, and then if you had another
Oh,
decimal,
you
alright, I
mean
got you.
4 to the. Oh,
I make sense now.
R prime.
It's, yeah, it's 625.
Other questions?
Why'd you get 615 though?
That's-
Oh,
that's-
that's it.
5 times 5, 25. 125, 625.
I remember
I'm
thinking
having
this is not about
issues.
math, but I
Okay, I'm
just
gonna
remember
stop.
this.